Okay, so welcome. It's just going to be the two of us, and that's okay. Like old times. But yeah, I've gone and put together a better presentation of what I was trying to talk about last week, and I think it should be helpful. See how this goes. Let me go ahead and share my screen. See what's going on here. We're doing the discussion of refactoring to patterns, so that you need to, when you are refactoring something, this is the ideal time to use design patterns. And so if you know you need to clean something up, then ideally you would start moving towards a particular pattern. And this is based on Josh Kurevsky's Refactoring to Patterns book, which I don't seem to have included here. But basically, he's got a couple dozen patterns, a couple of dozen refactorings and associated patterns that he discusses in his book. I'm going to just discuss the ones that he finds to be the most common. Just a second, we got important breaking news from Davi. This is his new baby.
Wow. Kongs, awesome.
Oh,
That's
baby.
pretty.
Excellent.
Breaking news. Seriously.
Perfect. Yes, that's fantastic. I
Awesome.
need to tell him congratulations. Oh, where's the starstruck look here? Come on, where's the starry eyes? There we go. And we need another celebration.
It should be too busy now.
Okay, there we go. Excellent. All right. So we'll get back to work here. So
Okay.
yeah, basically the we'll go over the four of the more common refactorings that tend to we tend to well, at least Joshua Kurisky claims that he tends to do the most often. The replace conditional calculations with a strategy pattern. We've talked about this in the past, but we'll go into it in a little more depth here. Replace your implicit tree with a composite. This is mostly when you're working with XML. Do you work with XML much, or
Not like I consume TXT and in batch jobs, yeah, TXT and Excel files, not XML.
Yeah. Well, us old guys work a lot with XML and in JSON. So I'm guessing that if you're using XML or JSON, you need more of a tree structure with how you're rendering stuff, reading and writing that. Then this will come to bear more often. Encapsulate the composite with a builder. So basically, we're taking the composite that we built here and further simplifying it by using the builder pattern. And then finally, compose method, which is sort of a combination of a bunch of small, small refactorings that we can use to move forward and get it to come together. So, all that being said, let's get started. Replacing a conditional with calculations. So basically, if you find your business logic gets to be complex, or you find a bunch of if statements, um, or case statements, this um, this is oftentimes an object begging to be pulled out of there. And so what we do is we start dividing it up into objects using the strategy pattern. Okay, so we'll take a look here at some code. Is this big enough? Can you see it?
It is, but the font is a bit small.
Then let me update the font here. Oh, I will do this. What is it? View, put it in presentation mode. Come on. There, how's that?
Perfect.
Okay. So basically we've got this loan object, calculate the capital, get the risk amount, unused risk amount. So all this being said, basically the structure of it, well, where do we go? There it is. Okay. The structure of it that we're trying, right now we've got this loan object, and what we want to do is move towards a strategy pattern. So basically you've got like a common strategy that is common to what everybody is doing. And then you've got more specific objects that will go and apply to specific cases. And this is where you'd stick the stuff in your if statement, the different things that handle that. So all that being said, we come back here. And so what we'll do is branches, no, get log. There we go. So first thing we'll do here, so basically your main function is this calculate capital. Okay.
Yeah.
We calculate the risk amount, which is here, which also calls the calculate unused risk amount, which is here. So it takes all those values, and then we calculate the duration, which is all of this, where we get the time and communicate, calculate the daily maturity stuff. And finally, we get the risk factor for risk rating. Okay. And so basically all of this is put together to get our capital calculation. All right. So what I'll do is I'm going to use my trick I learned in my presentation at Java 1 is to go and create a new class. So we create this risk factor class. All right.
Okay.
Right. So basically, this is what we're going to use as our what we're going to start moving towards. Oh, I'm sorry, I'm getting ahead of myself. This is the way this is going to work. Basically, these are the steps that we use to refactor. You're going to find the calculation method to be simplified. And we call this the context class for our strategy pattern. That's sort of the common calculation that we do for everyone. Then we create the concrete class, which is what what I was just showing you. We name it based on the behavior of whatever method you're using to do the calculation. That's going to be your strategy. Then you do the move method refactoring, where you basically take the method out of the original class and you move it into this new context class, and whatever helper methods and variables that it's going to need. The field is your member variable for a class. You update the original calculation method so that it delegates to the new strategy object. And of course, you compile and test. You apply the replace conditional with polymorphism refactoring. Okay, so now that we've got this object, now we've got our if statement, which has the different special cases, and you'll create specific classes to handle each of those that all extend your context class, or your basically it's the strategy object that we're looking for here. So these classes down here. And you refactor slowly and carefully, one subclass at a time, making sure that you get it all done right. And then, if you've got common calculations, you use the form template method refactoring, and you make the original strategy class, you make these functions abstract. Like here, this risk amount is abstract because it's going to be implemented by one of these, and the duration is going to be implemented by one of these. But the calc method is not abstract. Okay. And then you add the code to your strategy class to choose the appropriate subclass. So however you're going to have it determine which one of these you're going to use. Okay. And then of course you compile and test. All right. So so basically what we will do is handle this calculate capital calculation. Where to go? This capital calculation, and we'll create a new class that we will call capital strategy, and it's not there. So maybe if I go here, check that out, it will be there. Yeah, looks like it's not. So I guess my recovery didn't work. That's really frustrating. Hello, the branch has been restored. Okay, thank you. So is it there now? Nope. So we go here. Yeah, nothing has changed. All right. So why is that? Doggone it. You got it here. Go to child commit. Go to parent commit. Give me just a minute here, because this, man, show repository at revision. Nope, that's not what I wanted. I want to check that out. Boom. Something happened. No, it didn't. Okay, so it didn't work. That's discouraging. Okay, well, we will just do it by hand, okay?
Okay.
So that being said, I'm going to have to change the view because I need the functions of the IDE.
Like, are you at the latest commit or you move back? You're adding it to that commit you checked out.
Go ahead here. Oh, wait. Let me try this here. Create the new class. Show. Check that out. There. Look, there it is. I'm sorry.
Ah, it's okay.
We did. Let me just go ahead and increase the font. I can do that. How's that sound? Is that good? Is
That's cool. Yeah.
that big enough? Okay.
Yeah, it was
Right. So then what we do is, so we'll move the methods from the loan class to our capital strategy class here. And so we do that. And so basically we've taken this function, this risk amount times duration times risk factor, and moved it to our capital strategy. Risk amount times duration. But now that doesn't compile. So what we'll do is we'll pass the loan object as a parameter to this, and then we'll refer to that for each. But if you look on the loan object, the risk amount is a private and the duration is private. So what we will do, we've got to go and either make those public, or in this case, since this is a support method, this risk amount, we'll just go ahead and move the risk amount over to the capital strategy object. And here, and you see we've got the risk amount is here now. So it doesn't need to be part of the loan, so we can clean that up. Oh, I'm sorry. We also need the the set unused, the calc unused risk amount and the set unused percentage. So we went ahead and moved those over from the loan to capital strategy. Okay, and then what do we do here? The unused percentage variable here was basically, since we're doing this calculation of the unused percentage, let me go back and show you what I just did there. So we've got this unused percentage variable here that if you look at the code for the set unused percentage, it goes and sets the value for this unused percentage, which is a local variable, and calc unused risk amount. So we're using that unused percentage. So it's like, why don't we just have this, change this to be our get unused percentage method and get rid of this variable that we don't need. And so so that's what we do in this step here. Right, call that calc unused percentage, and we return what we're calculating. So that's all we're doing, is returning each value instead of assigning it to a local variable. And then down here, the unused percent, oh, I forgot to do it there. We just call the calc unused risk amount. Then we go make the variables in the loan. We make these member variables public, so that this almost compiles here. It's just we've got to go in, and duration is now in here. Oh no, that's right. Duration is still over here in loan, so we can move that over. And the loan risk amount, well, the risk amount is down here, so we can basically get rid of the loan part there. And so we get that. Change the public variable access to the accessor methods. So basically, instead of making these public, we go and make those private again, but we get accessor methods here. And we use those. And then we move the duration method over. And finally, we go and remove the loan part on this, and everything compiles. Now, ideally, I would have tests to run to make sure this all works, but I do not. So sorry about that. In a future rendition of this, I will I will do tests.
Okay.
Okay, so basically we've done these first 5 steps where we've identified the calculation method, created a concrete class, we moved all the methods and refactorings over, and created whatever the local variables that we need to update the original calculation method so that it delegates to the new object. Now we start going through our if statement and applying the replace conditional with polymorphism to implement the rest of the strategy pattern, okay?
Yeah.
So here in loan, what we'll need to do is add our capital strategy pattern. Okay, and so the new loan now is able to delegate to this capital strategy pattern calculate method. So instead of having this big calculation here, it's going to call the one from the capital strategy object. Okay, and now so now loan just delegates everything to this capital strategy object, right? So this is where we start looking at this if statement. So you got the 3 different kinds of loans here, 3 different kinds of durations. So we're going to start the replace conditional with a polymorphism by creating our subclass. So here we go. We've got this term loan capital subclass. So we just know that this first, if it has no expiration date, then it's a term loan. And so it's got a specific time on it. So anyhow, so we call that a term loan. And so we'll take the logic that is there, that first if statement for duration, and we move that into term loan capital object. All right. So it's not very clean, but basically it's the same logic. We've just gone and moved it out over. And then we go here, we need to add creation functions for the specific loan types that we're going to do. That's this this final step here. Choose appropriate subclasses. So basically, we're going to create the different the creation functions. I'll show you what I'm talking about. My my mental state is is not there yet. Let's go where you never use that. So add the creation functions. So check that out. And that's not in cap, that's in loan. So here in loan, basically we've got our constructor that's going to be protected, and it's going to have all the parameters. We talked about this a little bit last week. And so now we're going to have like a new RCTL loan, a new revolving loan, a new term loan. So we'll call whichever one we need to, and it's going to have the specific type of object we're going to create. So right now we only have the term loan capital object. Everything else is in the capital strategy object still. So now we're able to make small changes and run our tests to make sure everything continues to work. And I'm doing a bad job of not including the tests, but that's where we're at. Don't do that. That's what I did last night. And just, there we go. So now we go ahead and create these other objects, our revolving capital and our CTL capital. So basically we take everything that was in this loan calc. Okay, in the duration method, we move it into here, into the duration method of the specific class, and we turn this into an abstract, so we know that it's going to have to be implemented by one of the subclasses. So now this has got this calc unused risk amount here, and we don't know how to get to that because that's private. Well, it can't be private. It's a subclass needs to use it. So we need to go and make it protected, which we do, and then we go and move the risk amount stuff. Let's go back. I did two things at once there. So let's come back here to this. We've got the calc unused percentage. So we've got another set of if statements, so we can take it and move the specific functions and calculations that we need into the specific classes that they apply to. And that's what we're doing here. So you see that this risk amount is now abstract. The term loan does a calculation for the risk amount and the calculation for the duration. Same thing that this RTCL, it's got its own risk amount calculation, and then the revolving has its own risk amount and duration. And I guess the calc unused percentage is our other thing that we had to calculate and move it into the specific. For the term loan, it doesn't have it doesn't call it calc unused percentage, so it doesn't really need that. It just needs the duration and the risk amount. Okay. Finally, we've got, if you notice here in revolving capital, we've got this duration. Everything does this, divided by millis per day, 365. We go here and it's divided by millis per day, 365. So we've got this duplication here. So integer division in a floating point context. Yeah, we've got that too. But basically, I'm looking at the duplication of the code. So what we do is we're going to take this, turn that into a function that we move into capital strategy. And so we'll go there. So now we've got our calc duration, which does end time minus the start time divided by per day. And so now we're able to take all of this and we will use the there. Hopefully we have this working right again. Okay, we don't. Okay, so go here. And the final thing is to, yeah, we remove the duplication, remove the, yeah, calculate the duration here. And then, yeah, we just call calc duration and pass in the parameters for it to work instead of using the calculations that we had before. Okay. Now, one thing we need to be concerned about here. Where are my notes? Right, we need to consider that you know, we created all these different objects to increase readability and maintainability. You know, so you know we've got a specific object to handle a specific type of calculation that we're doing. You can consider, I don't know if you noticed, we did a lot of work there. We made a tremendous number of changes. So, so we possibly could have handled that by just creating some methods that are well named, and that would have gotten us enough readability without going through all of this object creation. You know, so it's kind of a judgment call as to what's going to get the problem solved. Because you need to consider, okay, how are these classes going to get access to the variables that they need to? Are you going to, you know, make copies of the variables? Are you going to have them in a protected value that they get to? They can be passed as parameters, that sort of thing. You also have to figure out, okay, how are these subclasses going to be created? You know, you're going to have a factory pattern, or in this case, what we did is in the loan, we had all these different creation methods, specific creation methods that that we need to call for the specific type of thing that we're going to need to use. So we're effectively just sort of kicking it down the street to somebody else is going to have to worry about what kind of thing needs to be created at the right time. So so while this is a powerful refactoring, it's one that you need to consider that it's going to be a lot of work, and you want to be careful and make sure that you need that level of surgery to that kind of change.
Yeah, I get it.
Okay, so our next refactoring will be the replace the implicit tree with a composite. And like I said, it's useful, like if you're trying to represent XML output. This is something that I do often in the project that I work on. Again, it's an older project where we do a lot of XML file manipulation, but I mean, it's still a popular file format that people use even now, and that, or I mean, even if you're going to do JSON, that's got sort of a tree structure approach to how it does things. So this would be useful even if you're trying to render other type of tree structured output. So here's sort of an example. You got this string you got to put together. You got orders. This is XML. So you got the orders, and from there you need to indent it some, and got to have your order, and it's going to have an attribute with a 1, 2, 3 and item, and then you've got a value here in the middle. So the orders, order number, item number, and then the name. So we want to be able to turn that into a tag node object. And so it will have, we'll create a new tag node, which is your orders tag. And then we'll have an order tag. We'll add an attribute, which is our number value with a 1, 2, number name with a 1, 2, 3 value. We'll add another order, or I guess, yeah, so we'll add this this order to the orders object so that it's in a tree structure. And you get your tag node. Are you following this?
Yeah, I am.
I mean, before it was just sort of written out, but this is making sure that it follows a proper tree structure so that we don't have to worry about this ending tag. It's going to automatically be handled properly by the tree structure. So we add our item in, we add the attribute, which is a number and value. We add the value of the car door to the item, and then we add that item to the parent order. Then we just say toString, and it renders for us in whatever formatting we need it to. So that's pretty handy. Okay, so now if we're going to do this refactoring, first you need to figure out what is the primitive tree construction code that you need to refactor. In this case, yeah.
Maybe a second.
Mhm.
Yeah, maybe a second here. I just maybe wanted to understand the what would be the motivation for this, because ideally I would assume that you're receiving XML maybe from SOAP services, or they're
Yeah.
sending it over FTP,
Right.
whatever. So, but when would someone want to do this? Because I see like its real application in a project or code. Because like we have Jackson,
Mhm.
I think library that in Spring, that when someone sends like a JSON, you just get the object. If your model can map to that sort of JSON object they're sending, you get out all the variables that have sort of matching names in that, and the mapping is done by I think Jackson lib. Now, in this case, and the projects maybe you're working on, when would you need this sort of refactoring?
Okay, that's a fair point. I mean, this is a fairly contrived example. I will acknowledge. It's just the easiest to visualize. There may be, there are other situations, for instance, in the project that I work on, you can do some analysis on a chemical. And so we have an amount of chemical we've used for analysis and the amount left over, and then the results from that analysis. We can then take the chemical that was analyzed and split that up into well, I guess we take the original chemical and split it up into smaller portions and do other kinds of analyses and combinations of analyses. And so that we can go 2, 3, 4 levels into a tree structure of various analyses and trying to represent that on the screen of, okay, what is the parental relationship between this chemical analysis and other chemical analyses that are done on this same sample of chemicals. how is that all related? So
Mm.
something like this would make it easier to represent that, because all I'm worried about is the single node and its relationship to its children. And the object itself takes care of how it's going to be rendered, how it's going to be computed, and all that sort of thing. So
Okay.
yeah, and yeah, I just, like I said, this is a relatively contrived example because there are libraries that go and handle XML and JSON processing for you. You're right. Um, and also maybe you just don't trust the libraries. You're afraid of running into another log4j issue.
Yeah, I get it.
You decide, well, this isn't that hard. I can render it myself.
Okay, I get it.
Um, but and the other thing is that when you're doing it this way, it's just hard to see the it's hard to see what that's supposed to look like in the code. This particular example isn't very big, but you'll generally be having much more complex combinations of things, and you can very quickly, things can get out of hand and you don't know what you're looking at. So, all right. So basically the first thing you want to do is identify the primitive tree construction you want to refactor. So in this case, we're going to call it a tag node. This is a tag, an XML tag. And you got a parent tag and it's got a child tag. So an order has a child, or the orders tag has a child of an order, and order has a child item. And so you got the node types. And if we use TDD, he calls it test first design, you'll have one or more concrete node types. It depends on how complex your relationship structure is. And says you may not need to have an abstract node type. He discusses the details of that in his book, but basically you'll create a method to validate the contents in your tests, okay? And then since it's a tree structure, the nodes need to have children. So, and he cautions you, don't add the ability to remove children unless you really need it, because the Yagni principle there. And they can set attributes on the nodes. So I mean, this would be an attribute with a value that you can set. Then once you've got your way to get all your nodes hung together, then you'll go and replace your original code with your new code. And of course, compile and test all along the way. So let's see what this looks like here. I have my my example code that does that here. So basically, we're taking this example that was in our little project here, and so what I'm doing here is I'm adding a test method. I was having difficulty putting this together to get the JUnit stuff to work, so I just added the test method to the main method in this class. So, and I needed to create the assert XML equals method. So there it is. So I go and I make sure that my XML strings that I'm expecting and that I'm creating work. And then I create test one node. of the tree. So basically you got orders and you close off the orders. So you make sure that that all works, and we go and run that. And if it doesn't work, all I do is I throw a runtime exception that says they don't match. So yeah, we're happy there. All right. So next, we want to be able to handle children. So we will go ahead and create our test for that. So adding children to the tree. So you got orders, have an order, the order as an item, and then we undo all of that. So tell the tag node to have orders, and the orders will have an item. So add the order and the item. So the orders, to each other, and we'll make sure that that works. So we can go and look at what that looks like in the code here. So things are getting a little more complex with how the relationships are done, but basically you're going to add a child node. This will have our list of children, and they'll be added in order. And we have our test, and we make sure it still runs. Hello. And we're happy it still runs. Okay, then this is where we have it add support XML attributes. Okay, so basically we've got the different nodes, and now we're going to have the values and well, I guess here's the attributes and the values in that XML would need. And so we'll go in, this is the string that's going to build, but this also how we do it using tag nodes. Okay, and so what does that look like? Well, we have the function to add attribute, set a value. Actually, say set a value. Yeah, I guess we change that to add value later in another test. But we go and we run our we run our tests like this. And we're happy. Okay, so the next step, we're going to replace the that tree construction with our composite code. Okay, stop that. You gotta be. I made changes.
Didn't see that.
Wait a second here. Well, I must have accidentally hit the keyboard or something. So, I'll force the checkout. There we go. Oh, yeah, that's all I did. Okay, so basically we're going to our main and we're replacing this. Here, I'll go back to where we were. Main. And we got everything here as a string, and then we'll go and replace it with the tag node stuff. So that that should ideally simplify things. And you can argue whether or not that makes it more readable than what you had. If it was more complex, it would be easier to manage it, but again, it may or may not be more readable like this. So with that in mind, let's look at our next refactoring. We're going to encapsulate a composite with a builder. So your composite object a lot of times can expose a bunch of details, like how all of these things are related to each other, and it can really be hard to read. So what we do is we'll have a builder pattern to make it a little easier to read. So we've got this tag node stuff, and we have to actually indent how the tag node thing is working so that we can make it a little more readable. But if we have a builder object, everything seems to look a lot easier to follow. So you got you're going to create a new builder called orders. You're going to add below, or you're going to add an attribute. And so you're going to add an order below orders. You're going to add an attribute, and you're going to add an item below your attribute. And you're going to add an item below your order, and then you're going to add an attribute to that, and you're going to add a value to that. So, so let's see what that looks like. We'll effectively continue on where we were. So we'll go ahead and
Scott,
yes.
A second on that, yeah.
Mhm.
A second on that. So does the builder mean just adding the word builder, maybe on your objects or something? So what is like the real idea behind a builder, like as a pattern?
Builder pattern, you'll use that if you have like a number of parameters that you have to set in calling a method, and so you want to create a parameter object and use the builder pattern to set the values there. Or like in this case, this just sort of makes it easier to assemble this tag node structure. It makes it a little more readable, so that rather than have this tag node creation here, this tag node creation here, you can just say, okay, I'm going to do this, create a function that is more readable and understandable for how you're going to assemble it. And it makes it ostensibly easier to follow. Basically, the builder pattern is for when you need to initialize an object with a number of different values. And you may not necessarily need all of them. And it just makes it more readable and natural to sort of put it all together. I've used it in a number of places in my code when I've had to, I've got a bunch of overly complex objects that take a number of parameters that get passed to go and initialize it. And it just makes it easier to read the parameters being passed and how you're going to initialize it, and not worry about the things that you don't have to. You just leave that off. Otherwise, you'll have, in one case, I think about 8 different calling methods that all chain together based on what I'm initializing. It's like, well, if I had a builder pattern, then I wouldn't have to have 8 different calling methods. I would just call it and initialize the parameters that I need to in a builder pattern, and I wouldn't have to worry about things that I've left out, because Java doesn't really have this default parameter concept in the language. Something like Kotlin does have that, so you wouldn't need it. But the builder pattern is what I'd use in that case. Does that answer your question?
Yeah, I think it does. So does it have to, if for someone calling that object, does it have to always end with build? Because I see like in Spring, like Spring Security, normally when you maybe going to return like a web security sort of object, you end in with build. So is it like a requirement for the builder pattern, or it's simply
that's sort of the convention. if you're going to be using a builder pattern, that you'll go and you'll initialize everything, and then you'll call the build method to get the ultimate object.
Oh, okay. I get it.
And that's
Thank you.
from there's let me stop sharing my screen for a second. Pause share. What's that look like? My screen sharing is paused. I don't know. Can you see anything? Can you see my screen, or is it?
Effective Java? Yeah. The book you're holding?
Yeah. So
Yeah. But
I just
Joshua Bloch.
basically I got this book by Josh Block that talks about effective Java, and one of the first things he talks about is the builder pattern, but it's also one of the fundamental patterns in the Gang of Four book. It's a very popular pattern. He just talks about here how to specifically implement it in Java. And, like I said, it's conventionally the way we do it is you initialize all the values, and then you call a build method at the end.
Oh, okay. I got it.
Okay. So let me go back here. And I need to get back to the code. Okay. So, so basically here we're going to create the XML builder class, which is here. You'll give it a root name. So what this will do is it will go and build up a collection of tag nodes in a tree structure and then render it using its toString method. Okay. So what we will do is create a method for adding tag nodes to the builder pattern. And again, all of this, see, we have a test that that goes and shows how to do this. So we're going to have a single element tree, then we're going to have the add below method for the builder. So we go and we test that and make sure it works. And this is what the add below method looks like. You're going to create a new node. Basically, you pass in the name of the node. You take that new node and add it as a child to the root node. So whatever the current node is, you're going to add this new child node and then set that child node as the current node. Assume that's the thing you're going to be working on next, right? And then we want to be able to add a node, I guess what you call it, a sibling node. So a node at the same level. So we call add beside instead of add below. It's basically have a sibling node. So you'll add the sibling node to the parent, and then make the parent, you'll make the sibling node the current, because that's the next one you're going to be working on. You also change the add below so that you're adding the current to the parent. Basically, you're adding the new child node you just created to the parent. And you had to go and create these other. So,
Manecall.
so we take
It's
that.
okay. Yeah.
And you can see our code is getting more complex to handle these different cases.
Yeah.
That's why we're using TDD to create and make sure that it's all continuing to work. And finally, we've got the original client code that goes and creates all these tag nodes in order. So we'll go and since all of our tests are working, there we go, boom. And we will go and replace it with the builder. And so you've got orders, add below, you add the attribute to that, then you add the child, add the attribute to that, and the value to that. And that reads a little more easily than the previous thing. Okay,
Yeah. Mm.
so, um, so this is what we just did. All right, and finally, there's a compose method. So this is the one that we've probably seen the most in our refactoring exercises. This is the one that you're going to use the most, and you have a method that's hard to understand, or it's big or complex, doing too much, so you break it up into smaller chunks. And there isn't really a set of steps that you follow to do that. But there's different methods that you can follow to simplify. Think small. So basically, you've got the methods that you're going to extract. Generally, you want to have them less than 10 lines, usually more closer to 5 lines. The 5 lines of code book I was talking about last time. Of course, removing duplication, that's something that you're going to find often. That's just the way people tend to create new functionalities. They get functionality that does something similar, they copy it, paste it into a new space, and fiddle with it until it does what they need it to do. And then you've got all this duplication that you don't have a good way of cleaning it up. So there's always lots of duplication, especially from younger, newer developers. You want to communicate the intention of the functionality with the names of the variables and methods. We talked about that as well. You want to simplify how you're going to be doing it. You want to find the most simple way to do it. I mean, that's the whole point of what we're doing. You want to keep everything, make everything simpler, easier to read, and easier to maintain. Similar levels, that's sort of the why didn't I write that in there? Your you want to have things at the same level of abstraction. If you're either going to call functions, or you're going to do assignments and assign a value. You don't want to do both. So you want to keep things at the same level of abstraction. And then you want to group related code together. So if you can't extract code into its own method, you can find a way to sort of take the code that's working on the same thing and keep it all together in the method. Says, yeah, especially if you have code at different levels, you want to find ways to group the stuff at the same levels together. So we'll do a quick look at an example for this. So so basically we have this relatively complex code. It's got some things that I guess they're not really duplicated, but it's just in general hard to read.
Yeah, could you kindly make the screen maximize it to the maximum?
You're right. So basically, we've got this contains method, and you're getting a location, and there's Boolean completely within, and if it's completely within, we return true, or if it's partially within, we return whether it's partially within. So we're just trying to see if something on the screen, if it's contained in the component, or if the object that we have is contained in contains the component we're interested in. So so we have to get the location of this component, and we get the X and the Y for the location, and then we figure out where it is. So that's kind of where we are with that. Do we have a new message here? No. Okay, so So that being said, so what we'll do is we've got this completely within calculation. And so what we'll do is we'll just kind of take all this and we'll do the extract method for that. So now we have a method for is completely within. All right. And then that reads easier. So we get our location. If it's completely within, then we return true. Okay, so that's easier to understand. Okay, and of course we have our, well, we should have a test for that, but we don't. Sorry. Okay. And then, we've got the same issue here with partially within. So we can go and take that and extract that out into its own method. So we've got our is partially within method, is completely within. So now we can just real quickly go through here. We get the location, get X, get Y, is completely within X, Y. Then we do this calculation, is partially within location X, location Y. Well, we can probably take this location X, Y and just pass the point and have it go and get pulled out and simplify it more so that way. So basically we get the location, is completely within, is partially within, and let those functions go and determine what the points are, or what the X and the Y are inside. Because I mean, this is just as readable as the loc X, loc Y, p get X, p get Y. So and we're getting the point here and we're passing it here. And so you may decide that, what I'm really interested in is, I just want to know if this component is within. I don't necessarily need to get the point for that. I can let the functions here get the point object so that I can keep this very simple. So I just say return is completely within or is partially within. So that's more of a judgment call. You can decide whether or not that's something you need to actually push down. And then finally, we just go and we inline the variables, or it's partially within, we just return that value. And it's completely within, we just return the value rather than creating a variable that we're assigning to. So, I mean, these are just simplifying refactorings that we're doing that, we've gone through a number of times in the refactoring exercises that we've done. So, and again, this is the book that we've been looking at. So that's pretty much what I wanted to go over, is the way that we can use design patterns to as a way to know where you're going when you're doing a refactoring. You're not just in a lot of cases you're just doing this small cleanup, but in other cases it's like, okay, if I have a pattern that I'm moving towards, then there's a specific set of steps that I need to get to make sure I'm creating that pattern. Let's see, where's is this it? Yeah, so basically you go to this, I keep going back to this refactoring guru just because it's so well done. And he lays out the different pieces you're going to need for creating a pattern. So you just make sure that you're implementing the pattern properly and completely. And that way everything, oh, here, I should be sharing my screen. I'm doing this, shouldn't I?
I was wondering.
Right. So, yeah, basically this refactoring, he lays out, these are the different aspects of a pattern. So in this case, we've got our factory method. You got the different, he's got, some examples to show you. And these are the different aspects that you'll need to create and, and pseudocode to do that and what it would look like and things to consider. So in this way, you can make sure that as you're refactoring, you're building the pattern you expect to, because the patterns are the ideals for what you're wanting to put together. So anyhow, I hope that was helpful. Any questions, comments, or concerns?
That was very nice. Thank you so much. And I like the mod you used today of having already committed stuff and just check out.
Mhm.
It saves a lot of time. It's a great style of presentation. I didn't know about it. I've always known this cracking out code. Yeah, but
Yeah.
it's really nice. Yeah, but then on the very first pattern we discussed our
Mhm.
strategy. One thing maybe I didn't quite understand is we are trying to get rid of those so many if the branches.
Right.
So the part I missed is how are we completely replacing, because the branches, those ifs, like how are we getting rid of them without them actually? So I didn't get that. I saw how we are taking away the code from here to here, but then completely getting rid of those branches that even if you're calling either the objects themselves that are supposed to do that you've delegated stuff to,
Right.
do you call them within ifs or it is simply without if?
Yeah,
I
that's
didn't
sort
get.
of the problem with using this approach of demonstrating. You can't really see the specific steps that I'm taking. So let's do that. So let's see if we can go here. So we've got our special classes. That's our capital strategy here. You can see the duration here, the term loan. So the duration, this duration calculation here was in here, and I just took it and moved it here. So what do is a similar thing. For instance, this is the oh, I don't have the new objects, so I've got to go and get the new objects so that I don't have to go and create them. I will put them here. So, oh, and yeah, that goes in. All right, fine. I'll just roll back again, and we will go ahead and create that. So, so what I have here is my my duration function, and the term loan extends a capital strategy, and it's got the duration function there. So what I can do is I basically go here and say I want to create a new Java class, and the other is the revolver capital. I think that's what it was called. Doesn't matter. And so we'll basically see how this extends capital strategy. So we'll go here and I have that extend the capital strategy as well. Now it's going to extend the capital strategy. Then we want to have our duration method. So we'll copy the duration method over here. And I don't need this part. I don't need this part. I just need this right here. So I've got the calculation there. then I can go here back to the capital strategy and see that, okay, we've got this calc unused percentage. And again, I don't need the whole, let's keep it in order. So I don't need this part here, the expiry is null and maturity is null. Well, that's applicable to the term loan. So I don't know what I just did there, but so all I'm concerned about is this part right here. Loan maturity is not equal to null. So I'll just delete everything outside of that. And there we go. So now revolving capital is done. And then we've got the new Java class. It's RCTL capital, I think is what, something like that. And so that's going to extend capital strategy as well. Zoom in here. Then we come back in here to our capital strategy. We've got our duration. And put that in. Again, I don't need this part. I just need this last part, right?
Yeah.
Okay, and then we do the same thing here with the calc unused percentage. Come in here. And again, I don't need the first two parts. I just need this last part. Okay. And so that just makes it very simple. And then here for capital strategy, I can say, you know, that this calc unused percentage, I can just make this, since I've moved all of the calculations into either term loan, oh, I haven't done the calc unused percentage here. So let's go ahead and do that. Here, again, I only need the first part for this one. Okay. So now I come here and I say this, get rid of everything here. And I say abstract. What did I do wrong? Had to make capital strategy abstract. Right, so I have to make the class abstract as well. All right, and the same thing for the duration. And get rid of all the code because that's all been moved. Okay. And so we have three related problems. What are those related problems? What is this? Oh. This can't be private. Same thing here. Okay. All right. So now we're good. And our loan class, instead of creating a new capital strategy, this will say a new RCTL capital. And this will be a new revolver capital. Because these are our special creator objects. And so if I had tests, now I could run those, right? And I don't need this here because it's going to be created in the constructor that we're going to call. This constructor is protected so that it's only called from within here. Does that make sense? I know I kind of ran through it quickly, but
Yes, yeah, it does. Yeah, thank you.
okay. So yeah, we just basically what you're doing is you're simplifying. Well, we're simplifying this object because all that code was in a big pile here in the loan. We decided, okay, what we really needed was the calculation for the, the the strategy pattern. So we just needed to get that calculation, and so we took the functions here: risk amount, duration, risk factor, and we just move all that into this root strategy pattern. And from there, we go in and create the methods. So this calc unused percentage and the duration are here. Calc unused risk amount. So who calls this? Oh, sorry. Here like this. Find usages. There we go. So that is in capital strategy. Calc unused risk amount. So there's risk amount. Okay. That's private. So who calls this? That's in the calc method. Right. Okay. So right there. So risk amount, calc unused risk amount. Well, fine. Let's go ahead and move these together. The abstract stuff. And then this calc method is going to be calling this function, which is only used here, and this function, which has to be implemented by a subclass. Then the calc unused percentage, I guess that's called, I don't know, who calls that? Calc unused, oh, right here. And then down here. So this is called from here. And we get the value, this unused risk amount and the unused percentage. Oh, right, so we call it calc unused percentage, and that's going to be down here, calc unused percentage. Okay, so yeah, we've got that about as simple as we can right now. You can always go through and do more refactoring, but I mean, this is simple enough. We're done.
Oh yeah, that's clear. That's clear. Thank you. Are you going to share the repo and the slides, or we just have to go ahead and try to do?
I can do that. Yeah, that's a good idea. I will stick this into a GitHub project, and I can do the slides as well. And what I'll do is I have not been uploading the videos lately. You know,
Okay.
since I got sick, my brain's been moving slowly. So sorry about that. But
Yeah.
I'll make a point to get all that stuff uploaded today.
Yeah, and given the fact that so many guys didn't attend, they'll need to know what.
Right.
Yeah, to go through what we covered. And it was very, very informative.
Okay.
Yeah, actually, yeah. Thank you so much.
Sure thing.
Yeah. Yeah. That's awesome. I'll be waiting for that trip. I want to go through it as well and see how it works on my end here, while just getting that to implement that the strategy sort of partner
Right.
in my end as well. Yeah. Thank you.
Okay. I will do that.
All right then.
Yeah, if I have energy, then I'll see if I can implement tests for all this as well and review. But for now, this is what we have.
Awesome.
Okay.
Yeah. Yeah. You
So,
stopped recording?
I guess we're done for now. So I will stop the recording at this point. So wish everybody a great day, and we'll get after it again next
Yeah.
week.
All right, then.